Hi everyone. Today we are going to discuss about the module 4 testing techniques and production methods. Module 4 is a combination of the two topics. One is testing techniques are the methods to use to assess the condition and the quality of the structures. Okay. So we having a different testing techniques are available. The testing techniques are classified into three types. One for destructive techniques, and second one non-destructive techniques, and third one semi-destructive techniques. So what is the destructive? We need to break the structure to assess the property, to assess the materials, everything, or quality of the concrete. We are breaking the materials to assess the structures. That is called destructive techniques. The example of the destructive techniques, compression testing, tension, and flexure. These are we are going to break up the structure. Okay, that is called for the destructive techniques. Without the damaging structure, we can able to assess the condition and quality of the structure. That is called non-destructive set techniques. And third one, semi-destructive. Partially, we can try to disturb the structure. That is called semi-destructive techniques. So this module 4, the testing techniques exclusively, we are going to discuss about the NDT, non-destructive techniques. We are not disturbing, we are not breaking the structure. Without damaging the structure, we are going to assess the condition and quality of the structure. That is called for testing techniques. That is called non-destructive testing techniques. Okay. And second chapter, the protection methods. These methods are the measured adapted to prevent the deterioration and enhance the durability of the structure. We want to make the structure is a good durability. For that, we are going to implement the several protection methods to prevent the deterioration, to enhance the life of the structure. That detailed testing techniques and production methods we are going to discuss about in the module 4. Quick recap as usual. Module 1 and 2, then 3 we discussed. Module 1 mainly discussed about the maintenance and basic fundamental concept of the repair and strategy procedures. Okay. Module 2, serviceability and durability of the concretes. So serviceability in case of the strength and durability of the concrete, we are discussed elaborately how to measure the serviceability, how to measure the durability, what are the tests we conducted for this serviceability test, and what are the tests conducted for the durability of the concrete, everything discussed of the module 2. Module 3 was special concrete where we need, apart from the conventional concrete, so we need a special concrete to increase the performance, increasing the strength of the concrete. We have used for the different type of the special concrete, polymer concrete, sulfur insulated concrete, high strength concrete, high performance concrete, FRP, okay, self-compacting concrete, and then industrial wastage, okay, concrete. These are all discussed various properties and manufacturing process and different advantages and disadvantages and various application of the special concrete. Everything discussed in the module 3. Now we are going to discuss about the module 4, testing techniques and protection methods. So this 2 chapter, we are going to detail discuss about the non-destructive testing technique, that's the NDT techniques. So many NDT techniques are there. We are not disturbing the structure to assess the damage and performance of the structure. Only quickly we are going to discuss of the importance of the two NDT techniques. Normally, where we are using for our construction of field. Then followed by the different repair techniques. One for the classical example for the epoxy injection and shoring than for the underpinning. Okay, these are for repairing techniques. And final one, the protection methods. Exclusively protection method for the concrete such as the corrosion pattern. Okay, how the causes of the corrosion. Okay, once corrosion occur, how deterioration going to happen? Building, then how we are going to monitor the corrosion? How we going to protect? Okay, various corrosion protection. How we are going to protect for our structure? Everything we are going to discuss upon the detail of in module 4. So as usual, module 4 objective as a learner to understand the NDT techniques used in the Congress structure. So learner to want to know the understand what is in by NDT techniques, what are the methods are available for NDT techniques, most probably what are the methods you can able to use easily for assessing and the performance of the structure, how to conduct the NDT test. So everything is talked about in the objective 1. Then second objective, learners repair methods, various repair methods, epoxy injection, shoring, and underpinning. All the methods should learn for learners. And third objective, learners to study the different corrosion protection techniques for the reinforced concrete structures. And fourth objective, learners should know the importance of the corrosion control for improving structural durability. Okay, so these are all the 4 objectives we are going to discuss in the forthcoming slide. First of all, we want to should know about the types of the destructive testing techniques. What is in the NDT techniques? The partially, okay. Only for we are not disturbing, we are not damaging the structure. Without damaging structure, using the several methods, we can able to assess the performance of the structure, that is called NDT. So earlier we discussed the 3 types of the system is available. One is for destructive, completely disturb the concrete. Okay, yes, we are going to use exclusively for the concrete. That's why completely disturb the of the concrete. That means we are breaking the concrete. After breakage, we are going to assess the performance of the structure. And second one, NDT test without any disturbance of the surrounding concrete. Okay, using the equipment, just hitting or just passing the waves. Okay, then we can able to find out the assess the performance of the structure. That is called NDT. A third one, partial disturbance of the surrounding causes. That is called partially destructive testing system. So the 3 destructive system only commonly using for our concrete structures. So this is a NDT. Now we are going to discuss elaborately for NDT system. It's a testing method to use it to evaluate the properties of the material. So if you take any concrete or steel or whatever maybe, we should know about what is the properties that we can able to assess using the NDT metrics, and what are the components of the included those type of the material that also we can able to assess the structures without causing any damages or altering their future usability also. What is the existing condition? Based on that condition itself, we are going to assess without deterioration, without damage of the structure. That system is called for the NDT system. What is the advantage of this system? No damage to the material or the structure. But in case of the destructive, completely disturb the surrounding concrete. But NDT, we are not disturbing the structure. It be cost effective and time saving when compared to the destructive. We need to brave for that manual power required and part of equipment is required, and time also comes in this. But here not necessarily. So cost effective we need for equipment alone, and also will be time also very saving. Early defect detection, so increasing safety and longevity. So whenever it's required, we can able to detect in earlier itself what is the performance and access of the structure. So based on that, we can able to take the call for safety and longevity. So durability will be increased. Okay, these are the many destructive NDT techniques are available. Rebound hammer, UPV, dynamic, pulse and radioactive method, nuclear method, magnetic method, electromagnetic method, electrical method, acoustic emission method, radar method, radiographic method. These are the many systems available. Commonly, concrete we can able to use for first 2 methods. One is a surface harness method, rebound hammer method, and second one ultrasonic pulse capacity method, that is called UPV method. Okay, so 2 methods are commonly familiar for our concrete structures that we are going to discuss in the elaborately. What is a rebound hammer? You see the look at the image also. It's like a hammer. Okay. What they are doing for hammer? Wherever we need for existing structure, material properties, or okay, to strength. Okay, we need to assess. For that, we are using the rebound hammer. Hammer. We are going to hitting the targeting the point. So based on that rebound hammer scale, give the reading. Based on the scale, we can able to find out the rebound hammer number. Based on the number, we can able to find out the compressive strength of the concrete also. Okay. So non-destructive test to check the strength of the concrete. So suppose now if you're having a new construction work, we can able to know which type of the concrete strength of the concrete they use, whether M30 or M40, M45, like that. Just imagine 50 years of the old building or 180 or 90 years of old building. We don't know existing strength of the concrete. In the situation, okay, we cannot able to go the for destructive and others. So we can go for the NDT techniques. We can able to assess the existing structure strength using the rebound hammer test. So this rebound hammer is a measures the surface hardness by testing the rebound of the spring-loaded steel hammer on the concrete. For this hammer having a steel loader, okay, this steel loader rebound and shows the rebound values. Okay. Based on the rebound values, using the graph, we can able to find out the strength of the existing concrete. Okay. What is the main objective of rebound hammer method? To estimate the concrete strength, whether it be M30 or M40, whatever may be the existing strength, we can able to access. Check the uniformity of the concrete. Any honeycombing is there or voids are there, based, so that we can able to check based on the rebound hammer. So whenever take the reading for the rebound hammer, we need to give more point. We need to mark the more point. That point we need to check the uh, concrete to assess the. We can able to check for uniformity of the concrete. Then evaluate the surface hardness of the existing concrete and identify the poor quality or damage for particular type of the structure. So everything we can able to find using the our rebound hammer test. How to conduct the rebound hammer test? The procedure we elaborate is a given. Procedure for rebound hammer test. Oh. So we are going to do the rebound hammer steps for existing structure. These are the steps we need to follow. Okay. First, where we going to take the rebound hammer value. For that, we need to select the boundary. In the boundary, we need to divide it into number of grid. Okay, like that 5 to 5 centimeter or 10 to 10 centimeter. We need to select the grid places. Okay, according to that, overall entire area we need to divide as a different type of the grid, maybe it's a rectangular or square, whatever maybe. Okay. For that we need to clean the properly clean and testing the surfaces where we are going to do the test, because sometimes if they're having a dust or dirty will be there, or loose particles or will be there, no, that under we need to remove that. So what that you see here we are giving for the spot within the 300 mm by 300 mm for area we need to select. So before going to take the test, no, to ensure the test surface is very smooth and it be very dry condition. Otherwise, what will happen? No, that rebound hammer value won't give the proper value. Once, if not given, we cannot able to assess the condition of the structure and strength of the structure. Okay. When you're giving the reading, one reading is not sufficient. We need to take the number of readings for particular area. So that is at least 10 readings in the different spot we need to take to assess the strength of the concrete. From that, we need to take for the average value of all those things. We can able to find out the assess of the concrete. Okay. This is for the only for selection of the area. Next, we need to equipment setup we need to prepare. So before going to take up into the our equipment, that is called a rebound hammer. We need to do the proper calibrations. Okay, service will be required. Calibration, if not doing, we're not able to get the proper value. So we need to get the proper value. Then hold the hammer perpendicular to the test surface. Wherever you're having a we need to conduct the test, we need to hold in the perpendicular for the where we are going to take the test. Okay. Next, step 3. Performing the test, press the hammer firmly against the concrete surface where we need to take this test. Just to going to touch in the concrete surface, just firmly need to against the concrete press, just gently need to press and gradually apply the pressure until the hammer trigger and it will rebound. That is the name is called rebound. After hitting that, what will happen? The hammer will be rebound. Okay. The reading the read the rebound value from the scale of the hammer. In the hammer itself, no, just to see this hammer. In the hammer itself, we having a scale. Okay. When you hitting the existing surface of the cylinder, gently we need to apply the pressure until the hammer will be rebound. Then automatically the reading will be changed. That reading we need to take. Like that, we need to take the minimum of 10 or 15 readings we need to take. Okay. So based on that rebound hammer value, we can able to find out the composition. So we'll be having a, because we need to take the more number of value. No? For that, we need to take the average rebound number. Based on the average rebound number, use the calibration chart provided by the manufacturer and to estimate the compression strength of the concrete. So this manufacturer, they will give for the calibration chart based on the rebound hammer, what is the strength of the concrete. Based on the chart, we can able to find out the compression strength of the concrete. Okay. So based on the rebound value, we can able to interpret the result. The higher rebound value indicate the stronger and denser the concrete. Okay, it's a higher rebound value. So vice versa, a lower rebound value suggests the weaker concrete or surface will be defected. Okay, that the conclusion we need to keep in the documentation. So based on that, what we arrived at everything, we need to documentation, report and documentation. So what that we need to mark, record the test location where we have taken, surface condition of the structure and the average rebound value, and compare the result against the standard and to assess the quality of the structure. So based on the IS score, the standard value is given that we need to compare. So based on the rebound hammer value, we can able to assess the our type of the structure. First picture is shows the our that is called a hammer. That is a rebound hammer conditions. Okay, if the value rebound hammer values comes for the greater than 40, then we can say for the good quality of the concrete. The rebound value is between the 30 to 40. That is be on the quality of concrete is be hard, is be layer. So 20 to 30, if you remember well, it's a good layer. 20 to 20 is fair. Less than 10, the rebound hair value, we can say for the poor concrete are delaminated. That is more damage in the concrete surfaces. Okay. So picture also shows the good condition of the concrete, then good layer, delaminated, less performance of the structure. So rebound hammer value shows the quality of the concrete. So based on that, we can able to take the decision, okay, to then to assess or strengthening of the concrete structure. So it is one of the very important method to assess the quality of the condition or quality of the structure using the for the rebound hammer method. Okay. So next method, ultrasonic pulse velocity method. Generally, we can call for a shortly UPV method. The name itself says velocity. The velocity we are going to pass the our structure. Based on the velocity, traveling velocity from one place to the other places, we can able to assess the condition and quality of the structure. Basically, the involves the measurement of the velocity of the electronics pulses passing to the concrete from the transmitting transducer to the receiving transducer. So suppose now this is take the concrete structure. Okay. Here we are going to place the two transducer, one for the transmitting transducer and second one for the opposite direction for the receiver transducer. Okay, in between, what we need to do, we need to transmit the ultrasonic pulse velocity wave, how the velocity is be traveling from the transmitter to receiver. Based on the time, okay, then we can able to find out using the calculation, we can able to find out the quality of the structure. Okay, so velocity range normally we can keep for 3 to 5 kilometer per second. We can able to. So normally we can keep the 3 to 5. 5 kilometer per second. So these are the different three types of the transducer. One is a surface transducer, angle transducer, and a face-to-face transducer. So three types of the transducer we can able to keep in our surfaces to find out the condition and the quality of the structure. So what is the objective of UPV? To measure the and strengthen the quality of the concrete. We can able to detect using the UPV method cracks, okay, and voids and any defects are there in the existing structure, and assess the uniformity of the concrete. Any honeycombing or voids are there, the uniformity is there. Everything we can able to find out the ultrasonic pulse method to evaluate the damage of the cracks or damage. Okay, so these are the objective of the UPV test method. How to conduct the UPV test method? Same like that, our rebound hammer test also surface preparation. Okay, what they did in the earlier, same like that, where we need to conduct, no, the surface should be clean. We need to remove the dust and loose particle. If you want, we need to apply for the gel or greases, getting the smooth transmitted from the one place to the other places. Proper contact between the transducer and the concrete surface, so we can able to use for any gel or greases we can able to apply. Same like that, rebound hammer, here also we need to set up the equipment. Transmitter, we can able to sue for three types of the transmitter places, no? Earlier discussed, direct or indirect, semi-direct, we can able to do it. To connect the transmitter and receiver transmitter in the UPV meter, we need to keep based on the position, and select the appropriate transducer frequency. We showed up 3 to 5 kilometer per second. No, that is frequency we need to type. That is based on the concrete thickness and type we need to select. Then we having three methods of the position of the transducer. Just to see the diagram of the step 3. First one is a direct method. Transducer placed to the opposite sides. Okay, so this is a one side. The directly opposite side we can able to place to check the quality of concrete. Otherwise, this direction here also we can place, and that's there also we can able to place. That is called for the direct method of the transducer. And so semi-direct method, the transducer places right angles or adjacent sides. One for this direction and this direction. One is for longer direction or shorter direction. That is also possible. And third one is the indirect surface method. It's both transducer placed on the same surfaces. In length direction itself, we can able to place it two transducers. Then we can able to assess the concrete structure. Or the short direction itself, we can able to place it transducer. We can able to assess its method. So three method is available to keep the position of the transducer to assess the damage of the structure. This is based on the our call, which method is suitable for that. How to do the measurement of the process? Switch on the ultrasonic velocity meter and ensure the proper calibration. Of course, whatever may be the equipment, calibration is important. Okay, place the transducer and the receiver. That is selected test point where we are going to take the test. For that, we need to keep it in the transmitter and receiver appropriate places. Activate the pulse generator. Now here only we are going to transmit the UPV waves and send the ultrasonic panel through the congress. Now what will happen once the generator wave is going to start to penetrate inside the congress here. Now you just imagine the waves are started to penetrate going to the one place to the other places. How to calculate the velocity using that formula? Velocity equal to L by T, where L equal to distance between the transistor from the receiver to transmitter. P equal to V equal to pulse velocity. T equal to time taken for the pulse travel from the one place to the other places. Okay, from based on that we can able to find out the velocity. Okay, based on the velocity we can able to interpretation of our result. Okay, if the velocity is above 4.5 kilometer per second, that is called excellent, good quality of the concrete. 3.5 to 4.5 is called for good quality of concrete, and 3 to 3.5 medium quality of the concrete. Below the 3 means poor quality of the or possible more defective. Okay, so based on the velocity, we can able to assess the condition and quality of the structure. And last method, NDT, based on the rebound hammer value, we can able to assess the damage condition of the structure. Here velocity. So two methods are, it's very important method to assess and condition of the damaged structure. Okay. Now we are going to discuss about the epoxy injection. Suppose after 10 years or 15 years, what will happen? Small crack will come. The small crack also is be widened. Certain. For that, we need to repair. So many repair methods are available to repair the cracks. Okay. Now, one of the prime method that is called epoxy. Using the resin for epoxy resin, now we are going to make inject and filling the crack to enhance the strength of the structure. So, seal the crack in the concrete by injecting a high strength epoxy resin. Okay. So, in this tube, we are going to fill in the epoxy resin. We are going to inject, in the concrete to fill for the voids or cracks in the existing surfaces. Okay, what is the purpose of the epoxy? Restore the structural integrity. So once the crack is formed, automatically appearance and structural stability will be decreases. Okay, so our ultimate we need to increase in the structural integrity. To prevent the moisture penetration, of course, once a crack is formed, automatically moisture will be started to enter the concrete surfaces, then started to deterioration of the structure. This is everything we are discussing in the previous model. Okay, so main ultimate aim to want to prevent the moisture. For that, we need to go for the epoxy injection. So what is the process? We are having a long active crack or dormant cracks. Okay, there we need to drill along the cracks, along the line of the cracks. We need to drill properly. So insert the injection parts, inject the epoxy resin under the pressure. Okay, we need to give the pressure. So what will happen? Allow the resin to the cure. Then we need to, this resin is going to travel and going to cover entirely cracks and finally it will be cured. This is looking again normal concrete. It will be earlier concrete itself. So where we are going to with the application, bridges and over passes of the bridges, we can use parking of structure, concrete war slab. So all the existing structure, if any damage will happen, we can go for the blindly for the epoxy injection. So systematic figure shows what is it? Source it will be it's a crack, it will be active crack. It started to widening. Because of this crack, other minute micro crack also will be started. So what is our ultimate? We are going to fill for this type of the cracks. What we need to, along the length of the crack, we need to pour the drilling of the holes. Okay, then installing the ports there. Here only we are going to inject the our epoxy. Then using the hammer epoxy, we need to inject the epoxy through that installing ports. So after that, no, it will be travel and away again. It's going to fix the finishing of the repair. This is one of the prime method repairing of the cracks. Next one is shoring. What is a shoring? A temporary structural support. It's not a permanent, it's temporary. So whenever we want to require for a workload, that time we need to keep it as a temporary structure to prevent the collapse during excavation or repair or modification. Okay? If you want to excavation of our existing or new things, or you want to repair the existing structure, or you want to modify the structure, so we need it for platform. Yes, for that we need to prevent the collapse structure, that is called for the shoring. The main purpose of the shoring to ensure the safety and the stability of the structure under the load. Whatever may be the load, the structure should be safety and stability. So we having four types of the shoring method available. One for timber shoring, used for the wooden beams and support. We can able to make it as a temporary shoring method. And hydraulic shoring, it be a very adjustable. It's a high strength and the steel supports are. Then steel shoring, steel beams and props are will be available. Solder piles and logging, the steel H beam or wooden and laggings are used. So these are the figures: timber shoring, hydraulic shoring, and steel shoring. These are all the call for temporary support. When work is over, so we are going to remove for these shorings. Okay, where we can able to use for this one, building excavation from that point of view, we can able to use for shoring. Trench I need to conduct and a tunnel support. For that we can able to use for shoring. Structural repairs and alteration, deep foundation construction, all those things we need for temporary structure to make the new thing or repair things. For that we need for temporary structure to keep it the equipment or workmanship, whatever that we need for one platform of the structure, that is called for the shorings. Okay. Next, we will go for underpinning. Exclusively for underpinning using for the foundation only. Okay, that is for the strengthening of the foundation. There is construction technique used to strengthen or stabilizing of the existing foundation. Already foundation will be there. Due to some of the reason, maybe settlement will happen or uneven settlement will happen, or I need to construct the new building above that first floor, second floor. We need to strengthen the foundation. For that, we can be able to go for the underpinning methods. When a foundation becomes weak due to the soil condition or maybe a loading condition or a structural modification condition, our foundation started to lose. For that, what we need to, we cannot able to demolish the entire structure. For that, what we need to go, we can go for the underpinning method to strengthening the foundation. Why underpinning is needed? Due to the soil shrinkage may be possible. If you're using the clay soil, maybe chances of the soil shrinkages, maybe the soil can be expansion or poor compaction, maybe settlement will be happen. For that, we can able to go for the underpinning method. When adding the extra floor or heavy machinery, maybe the foundation settlement or foundation started to weak. For that situation, underpinning method, we can go for strengthening of the foundation. Erosion if comes for land areas for mountain areas, excavation nearby, underground or water table variation that we can use for the underpinning. Okay, we can use when the original foundation is inadequate or a deterioration happen, we cannot able to demolish the entire structure. No, so for that we need to strengthen the existing foundation. We can go for underpinning methods. So earthquake or floods are affecting foundation stability. Okay, from that concern we can go for the underpinning. Can go. What is the advantages? Increasing foundation and the stability of the structure. Allow the additional construction on the existing structure. Once strengthening is a foundation, we can able to construct the few more floors also. Instead of having only for a ground floor, after strengthening of the foundation, we can go for a first floor or second floor, whatever may be required. So prevent the further settlement or structural damages. Already strengthened, no, we can the settlement we can able to reduce, or structural damage we can able to reduce. Then enhance the lifespan of the building. We can go for the underpinning. These are the advantage of the underpinning method. What is the disadvantages? Of course, advantage will be sometimes the disadvantage will be the more expensive depending upon the method what we are using. So we having so many methods are available for underpinning method. Even we can able to lift the entire structure. If you go those type of the method for lifting the one structure, we can able to place the other sides also. We have more expansive, okay, this method. So require the professional expertise, more workmanship will be required to enhancing the assessment of the entire process. Some methods to be involved for excavation, which can be destructive, also be we can able to use. Okay, so where we can able to use for this type of the underpinning method, where we need for the strengthening of the existing structure or strengthening of the old building, or in the weak foundation. To strengthen the foundation, we can go for the underpinning method. We want to make as additional floor. Now we have, take the example only for ground floor will be there. We want to make as a second floor or third floor. There from that point, the foundation is maybe a weak. So we cannot able to increasing the different type of the floor system for existing structure. In that cases, we can go for underpinning to strengthening the structure. We can able to construct the few more floors in later stages. So stabilizing the building affected by soil movement or seismic activities. When you seismic activities occur, automatically the settlement of the foundation may be causes of the failure, or liquefaction. Liquefaction is also not possible near the river area. That time also maybe chances are foundation will be settlement. Okay, in that cases, what will we going to do? We can able to go the underpinning method to strengthen the foundation of the site. So repairing damage to the excavation or near the foundation. These are the where we can require application for the underpinning method. Next will be corrosion. All we know familiar with the corrosion, how it will be happen, what is the causes of the corrosion. So it's mainly for the chemical reaction, chemical or electrochemical the reaction with the environmental, with like a contact with the oxygen and various moisture and acid or salt. Okay, now what will happen? So finally, what will happen? The original reinforcement bars will be rebars, leading to reduced strength and durability. Corrosion going to start. Once corrosion is be started, what will happen? It's reduced strength and durability. So this is various of the causes of the corrosion, maybe moisture and humidity, one of the reason. High salt levels, example for de-sizing the salt and the seawater, maybe chances of the corrosion of the reinforcement. Okay. Then exposure to acid and chemicals. So in our building, it's near to the chemical intensity or acid intensity, maybe chances through air or to water, whatever it may be. If having any voice or any porous will be there, moisture can able to penetrate this acid or chemical can to penetrate, and it's be damage for the reinforcement also. So differential oxygen levels. So this is also one of the causes what are corrosion. These are the causes of the corrosion of the reinforcement. Okay, so how will be corrosion process will be occur? So it's a reinforcement, a steel bar. If you're showing the exposure to the environmental, so steel rebar is be exposed to moisture, so automatically oxygen and salt in the concrete, initial process will be exposure. So next step is a chemical reaction occur at the steel of the surfaces. Moisture as well as the steel chemical reaction will be started. Once a chemical reaction will be started, automatically rust, the iron oxide, the rust will be formed on the steel surfaces and damage and cracking. The rust will be expanded. It will be tensile crack inside the concrete surface. So definitely it will be damage for the concrete and lead to the cracks. Okay. Then what will happen again? It will be expanded. Swelling will happen. The reinforcement. It will create the more tension cracks, and it will be cracks will be formed. After again it will be widening. The concrete will be disintegrated. We can able to navigate it through. We can able to see the how the corrosion will be corroded in the structure. Okay, so we having a different method, corrosion protection techniques method is available. One is epoxy coating, galvanization, corrosion incubators, cathodic protection. Using this method, we can able to protect our steel reinforcement. Okay, first one is epoxy method, and the coat the rebar. It's a normal steel reinforcement. We need to coat with the epoxy. Okay, so this epoxy to prevent the contact with the moisture and such like a barrier. Okay, steel and moisture having in between having a barrier, we can prevent the rebar contacting with the environmental condition. That is, we can able to prevent the corrosion reinforcement. Okay, for a galvanization, we need to for zinc coating. The above the reinforcement, we need to for the zinc. So zinc, we having a pore in the tank. We need to dip in the galvanization to protect the rebar from the corrosion. So we can use the various corrosion incubators, add the chemicals to the concrete and reduce the corrosive and all the environmental. Then cathodic protection using the electric current or sacrificial anodes to protect the rebar from the corrosion. Okay, so these all the four methods is a protection method. It's be one layer that we are going to form. That layer it won't allow reinforcement to the contact with the atmosphere. That is the main frame and for these four methods. Okay, then we can able to reduce or we can able to prevent the corrosion from steel reinforcement. Corrosion incubators is one of the prime method. The chemical is be added to the concrete, or we can able to apply it for the steel also to slow down the corrosion process. We cannot able to stop it. We can able to slow down the corrosion process. So we have a different type of the corrosion incubators, anodic, cathodic, and mixed for incubators, concrete at mixer or incubators is available for protect the corrosions. Then corrosion resistant steels. So we have a different type of the steels are available, stainless and weathering steel and galvanized steel. So these are the steel corrosion resistant steel. What is the advantage of this type of the steel? Long lasting and more durable, reduced maintenance and repair of the cost, and improve the structural longevity, integrity of the structure. Okay, it be using this type of the steel corrosion resistant steel. The initial cost will be higher in compared to the normal our steel. Specific types may be required specialized handling for processing. Each and every structure we need for specific types, so automatically increasing the cost also. It may still is vulnerable to certain type of the corrosion and the extremely condition. So coating is already we discussed on coating we are going to do. So protecting steel reinforcement bar with a protective coating to prevent the corrosion and deterioration. So four methods are available: epoxy resin coating and zinc coating, cementitious coating, and cathodic protection. Based on the four method, we can able to protect the for our reinforcement. So epoxy resin a layer to resist the moisture and salt content, protect from the reinforcement. For zinc, for our steel reinforcement, we need to dip into the zinc. And zinc, we can able to create the layer for steel reinforcement. So where we can able to use for this one, coastal and marine environmental, we can use for coating protecting materials. Cementitious coating, cementitious based on the layer additional protection we can able to potential coating and damage wherever required, we can use for this method. Cathodic protection when used for the coastal and marine environmental, it's additional cost or complexity is there. So four methods we can able to use for coating of the reinforcement to protect the corrosions. Final one is a cathodic protection. Here we are going to use as a anode, that we electric power. The techniques to prevent the corrosion of steel reinforcement using the cyclical anode are with electrical current. Based on the electrical passing to the current, we can able to reduce the reinforcement corrosion also. So cyclical anode cathodic protection, this one we are with cyclical anodes we are going to use for zinc as well as a magnesium to protect the rebar from the corrosion using for electrodes. So impressed current cathodic protection, that is we are going to apply the controlled electric current via the external power sources to prevent the corrosion of the reinforcement. Okay, where we can able to use for this cathodic profession, the marine structure or buildings, large building structure, pipelines, corrosive soil condition, underwater conditions, we can able to use for this cathodic productions. When you are using this cathodic proportion method, advantages extend the lifespan of the concrete structure and prevent the costly repair and structural failure will be there. Disadvantages. Sacrificial anode cathode protection is a limited lifespan for sacrificial anodes. The required power supply and maintenance will be required for that one for cathodic protection. Production. Okay. So this is the module 4 testing techniques and the production methods. So we have discussed about the NDT technique. What is in the NDT techniques? What are the methods we can able to use for to assess the condition and damage of the quality of the structure using the rebound hammer method, ultrasonic pulse velocity method. Then we have discussed about the epoxy injection, cracks injection, sealing or bonding a resin epoxy system. Based on that, we can repair the crack systems. So temporary support, so that is called as shoring, practical for repair, prevent from the collapse. We are discussed. Underpinning is used for the foundation, strengthening of the foundation. Foundation where for various soil is weakness to increasing load carry capacity, we can go for using for underpinning. Testing discussed for the corrosion protection techniques, the corrosion inhibitors, we discussed and resistance steel and coating of the reinforcement and cathodic protection. We are discussed for the protection method. So the module 4, there are two parts, one for testing techniques and production techniques. We are discussed in the module 4. So module 4 is outcomes. I hope all the learners can understand or identify the suitable non-testing techniques, methods for Congress structures. Okay, different structures available, different NDT techniques are available. The learner can able to identify which method suitable for which structure based on this theory content. Then learner can able to explain the procedure for the epoxy injection, shoring and underpinning for the strengthening or repairing of the existing structures. So learner can able to describe the various corrosion techniques used for the RCC structures. Learner can able to apply the appropriate protection methods to enhance the durability of the structure. So these are the all the outcomes can able to understand the learners. Okay, these are the textbook we are using for the all the modules on a Congress structure for protection, repair, and rehabilitation of the down Whitson, Congress structure and repair rehabilitation of the retrofitting for Bhattacharya, maintenance and repair and rehabilitation retrofitting of the structure for the Dr. G. Nandini Devi. This reference books are useful for the examination for the or practical implementation also. So thank you all for just we discussed about the corrosion module 4. Very soon we are going to discuss about the last module 5 chapter. Thank you all.